Sharp 9 p.m. Let's start off. So, guys, Assalamu alaikum. We're going to be starting off with a fourth demo class for the May-June 2026 session. In today's class, we would be continuing the concepts of hexadecimal. So, in the last class, we studied how we can convert between binary, denary, denary, binary, and then hexadecimal to binary. And also, we studied how if we are given a specific binary value, we can convert that into hexadecimal. But yesterday, this was one question which I got later on by one of the students, and he basically stated that, sir, what if a question comes up and they say that there is a hexadecimal value 071. This is a hexadecimal, okay? This is a hexadecimal value. And the examiner asks us to convert this into binary. So would we be ignoring this zero, or do we need to write the binary for that zero? So this was a pretty good question because koi nahi Zulkanan, aage set ho jayega, everything would be fine, don't worry. So this was a pretty good question because 071 can the usually the zero does not hold any value, because if I have to, like, let's say convert or break this into binary, it's going to be like this zero would be treated separately, this seven would be treated separately, and this one is going to be treated separately. So zero would be like 0 0 0 0. Why? Because 1 2 4 8, we just need a zero, right? For seven it's going to be 1 2 4 8 and then 1 2 4 8, and so it's going to be like 0 0 0 0. This would be 0 1 1 1, and then this is going to be 0 0 0 1. So the answer to this basically in terms of binary is going to be 0 0 0 0 0 1 1 1 0 0 0 1. Now we all studied this yesterday that these zeros at the most left hand side hold no value, right? Because zeros are like useless unless we have a one with it. Samajh gaye? So for that reason, can we ignore this while writing the final answer? Yes or no? So that was a pretty good question. And the thing is, at some point the examiner has not ignored it. But if I'm not wrong, I've also seen a marking scheme where the examiner was like, okay, you should go with 0 triple 1 triple 0 1. But now, what's the best approach to such questions? So, for all of you, do keep this in your mind that whenever a question like this comes up, you should always mention these zeros at the start. Why? Because by doing this, you're going to be at a safer point. You should not be missing these zeros at any point. Why? Because if I miss these four zeros and you later on reconvert the same thingy back into the hexadecimal number, so you're going to see that if I miss this part and I only treat 0 triple 0 triple 1 double 0 triple 0 1, it's going to get me a 7 and a 1. So my hexadecimal is going to be 71, whereas it should have been 071, which clearly proves that I'm missing out on this one zero. And so this can result in your marks being lost, even though if zeros do not hold any value. So for this reason, just keep it in your mind that the point which we were mentioning yesterday, that zero do not have any value, and that you can ignore it, that does not apply when we have a scenario like this where we have a 071 as a hexadecimal number. In that case, you need to show that the specific zero has a binary value of 0000. समझ गए? So this was pretty much very important, which I wanted you all to know, because okay, कहाँ से I have to open up this. Yeah, so center stage. So never mind. This was one point which I really wanted that you all should be aware of. So if a question comes up, do not make this mistake. Now, coming back to the last discussion, we ended our class on this diagram. So we studied how we convert a binary. So we studied how we convert a binary number into a hexadecimal number and vice versa, hexadecimal to binary. Inshallah, in today's class, we're going to be starting off with the conversion between denary to hexadecimal and then hexadecimal to denary. So now we have two methods to doing that. So let's start off up from here. Say hexadecimal to, or yeah, denary to hexadecimal. Now, if I have to convert a denary number to hexadecimal, if you are studying the concept in school or maybe while reading the book, you would have noted that the one method which has been taught to students frequently is the division method, where they're basically teaching you guys to divide consecutively by 16, and then you have to look up at the remainder and you're going to be finding a value through that. Just like Zulkarnain just mentioned, that divide by 16. While that method does exist, the chances of making an error there are pretty high. Why? Because we are well aware that if I have to divide something by 16, the chance, oh, let me send a message into message, and would get join in, folks. We have started off. Never mind. So for that reason, the chances of making an error are pretty much very high. So exactly, Zulkarnain, if you made a mistake, then here you go. We have a shortcut for that. So if I have a denary number and I want to convert it into hexadecimal, the approach which I was following back when I was giving my exam was that if I have a specific denary number, converting a denary number into binary is pretty much easy using the same method which we studied in the previous classes. So yes, so 1248, and then you're just going to put ones. And then converting from binary to hexadecimal is literally even more easier because we are well aware that we just need to find pairs of we need to find group of four. So let's do an example. If I have a specific denary number, let's say 84, okay, and I want to convert this into some hexadecimal number, how will I be doing this? First, I would convert this 84 into binary. How will I be doing that? Same concept which we studied yesterday. So I would be assigning the values 1, 2, 4, 8, 16, 32, 64, 128. And I'm going to be putting one beneath all of those, which when I add them, I should be getting 84. So I'm basically converting the denary number into binary. So this has to be 0. This would be 1. Okay. This means I need to do 84 minus 64 is 20. So how would I be turning on these bits so that I get 20? So 16 plus 4 would be 20, right? So if I add 64 plus 4 plus 16, it should get me an 84, which means I can put 0 in all those other parts. So the binary for 84 is basically 0, 1, 0, 1, 0, 1, 0, 0, right? So I get that. And now if I have to convert this binary into hexadecimal, you guys are well aware that it's super easy. How? Because I have to just find the group. So one part of group up here, 4, 1 nibble, and then 1 nibble is like this. So if I have them separately, I'm going to write 0, 1, 0, 1, and then 0, 1, 0, 0 with the values separately, 1, 2, 4, 8, 1, 2, 4, 8. And now if I add them up, 4 plus 1 is 5, and then 4. So the hexadecimal for your denary number 84 is basically 54 or 54. Now, when you do it through the other method, where you're going to be making use of consecutive division by 16, the chances of errors are pretty high. Why? Because definitely if I'm doing something like 84 by 16, and then I'm doing it like, okay, this might seem easy, but 16 5 is what, 5, and then the 30, okay, 16 5 is 80, and then it's going to give me a remainder of 4. So it's just the same way that if I'm dividing it, I see that LCM wala method here, sort of 16, and then I see that 16 5 is then what do we call it, 5 piche reh gaya. No, sorry, it's going to be 16 se divide ho raha hai, so you're going to get a 5, and then the remainder is going to be 4. And so we'd say that ek aapke paas 5 aa gaya, and then aapke paas 4 aa gaya. And it's going to give you the exact same answer. But I personally do not use the division method because it's really possible that you mess up the calculation there. And so I would recommend that if a question comes up asking you to convert between a denary number to a hexadecimal, always go through this path of converting from denary to binary, because the chances of making an error up here is very, very, very low. So I personally have never followed that specific path. So if I was same with same with hexadecimal to denary too. So now you might have been wondering why I was not able to, or I was messing up this LCM method. So the thing is, back when I was preparing for my IGCSEs, मैंने उसी वक्त इस method को छोड़ दिया था. Why? Because I thought that if I'm following this longer method, okay, it's not that difficult, it's pretty easy, I just have to divide. But what if I make a mistake? Well, isn't it easy to convert a denary to binary and then a binary to hexadecimal? Which if you guys even look up here, the chances of making an error even for a larger number is pretty much low. Now this was a pretty small number, 84. But what if I ask you to convert like a 284? Now dividing 284 by 16 would be a different case. Why you need to divide, and you're going to be thinking of how am I going to do it? But rather if I have to do it the other way around, I can easily put ones up here and then divide it into groups of fours to convert it into hexadecimal. And the same thing applies if I have to do it the other way around. If I have a hexadecimal, and I have to convert this hexadecimal into denary, the approach which I would recommend you all to follow is that सबसे पहले take that hexadecimal value, convert that hexadecimal into binary, and convert that binary into denary. And this literally will get you the correct answer, same to same correct answer, but with very minimal chances of making mistake. So for instance, let's do an example. If I have a specific hexadecimal value like 7a, now if I have to convert this 7a, first of all, if I have to do it, okay, so there are two methods, let's discuss both of them, but chalo, the first I'm going to be discussing the easier method, okay, easier method. So the easier method is going to be like 7a. So I will be converting this into binary. So 7 ko alag se aap logon ne kar dena 7 and then a. So what's going to be the binary for 1248 and 1248? So we know that 7k binary is going to be 0111, and for a it's going to be 8 plus 2, which because we know that a is basically what? A is basically a 10. So the binary for 7a is going to come up as 01111010. And now I'm going to be just finding the denary value of this binary value, which would be 1, 2, 4, 8, 16, 32, 64, 128. Now I would be adding all those bits where I have the lower bit as one, right? So this, and this. So let's add them up. So it's going to be like a 64 plus 32 plus 16 plus 8 plus 2. So let's add them up. This is going to be 96 plus this is going to be 26, right? So 8 plus 2 is 10 and 10 plus 16 is 26. And now I'm just going to be adding these two. 6, 6, 12, 1, and then it's going to be 10 and 122. So the answer to this specific part is 122. So 7a is basically 122 in base 10 or in base denary. So this is one method of, so how many marks it's tested? It's usually tested for like, yeah, 2 to 3 marks. Sahi bol rahe. Yes, Zulkana, it's going to be 122. Perfect. Perfect, Moise. Perfect. So, we got this answer, which is done through the easier method, right? But in your actual, but in your actual book, or like the one method which you might have learned in school, the method taught to you is basically, again, dealing with basically multiplication with 16. अब उसमें क्या होता है? You basically take a specific part and then you multiply it with its position. So like आप 16 raised to power 0 से multiply करते हो, then you multiply the next digit with 16 raised to power 1, and then so on 16 raised to power 2. So अब होता ही है, so let's say the method 2, which I won't recommend, okay? Again, chances of making error are pretty high, so not recommended. At least I haven't been using this, and I would never recommend any of my students to also make use of this method, because why are you going to go with a method where the chances of making an error are high? Why? See, so that method basically deals with that. If I have 7a up here, all of these 7a basically have a position, right? This has a position, this has a position. So this has a position number 0, this has a position number 1, and so on. Whatever, if I continue, the position gonna increase. So the formula is that you're gonna take 1a, this specific thingy, value of this a, which is going to be 10 or whatever this figure is, you're going to multiply it with 16 raised to power position. And you need to do this like till your final thingy. So you're going to continue this for all the digits you have in that hexadecimal figure or whatever question you have. So like in this case, we're going to be starting from the most right hand side. A is what? A is basically 10, right? So it's going to be 10 raised to power 60, multiply by 16 raised to power what? The position. So the position of the very first element is 0. Then this is done for a. Now we're going to be doing it for 7. So 7 multiplied by 16 raised to power 1. Yes, do you have a question, Zulkarnain? Exactly, Moish. बिल्कुल इसी तरह. So it's going to be 10 into 6. Sir, can we just focus on it? That's the same thing. I would recommend you guys to focus on just the first method. ये तो इसलिए करा रहा हूँ, if ever you guys are being taught the method in the school, you guys should be aware that this method exists, but it's not recommended, and I would never ask you guys to even use this. The one which I told you earlier on, just go with that. ये useless है, सही है? But it's just to complete the course corner that you guys are aware that such a method does exist. Okay, so what happens is that you're gonna 16 raised to power 0 is basically 1, so 10 into 1. And then you need to do 7 into 16. So when you put these two through a calculator, you're going to get the same 122 answer, which we were getting up here too. But now you tell me one thing. Is base, what do we call it? Is this method number 2 easy, or is this method number 1 easy? Let me write method 1. Method 1. You guys tell me, which one seems easier? And which one is a method where definitely the chances of making an error are low? It has to be method 1. Exactly. It's way more easier, it's way more appropriate, it's way more precise, and the chances of making an error are also low, because I've like, just look, if I have to do 16 into 7, I cannot do it mentally unless I've memorized the tables. I have to do it like this way: 16 into 7. 6 6 are 36, 6 7 are 42, 4 7 1s are 7, 412, and then I have to add 10, 122. Now this may seem easy, but why do I have to go through these calculations? What if I have like something like B7A. So it's going to just become more complex. For that reason, I would not be recommending method 2 at all, even though it is being taught everywhere. It's there in the book and or every place out there, but you should go with method 1. So if I have to convert from denary to hexadecimal, convert the denary number into binary, and then I'm not saying it's difficult. Method 2 is also easy, but if I give you guys a question like this, okay, Saifullah, you tell me that if there is a question like this, F79A, and you need to convert each of them. This is going to be done in a way 16 raised to power 0 into 10. Then it's going to be for the 9, it's going to be 16 1 into 9. Then for the second one, it's going to be 16 2 into 7. For the third one, it's going to be 15 into basically 16 raised to power 3. And just tell me, you don't have a calculator. You don't have a calculator. So making such calculation would be very much difficult. So even though it's not that difficult, it's really pretty much straightforward, but still I would not recommend, because doing these calculations can take a lot of time. 16 square is like 256, and then 256 into 7, okay, that's doable. But what about 16 raised to power 3? That's now very difficult. See, so now the examiner might not give you such difficult question. This might have been a bit exaggerated, but still, if a question like this comes up, it's easier to solve it through the binary method. So whenever you get a question, my advice would be that go from the denary to hexadecimal through the binary conversion part. And just like that, if you have a denary hexadecimal value, convert that into binary and then go towards denary. And also one other thing is, then in a lot of questions, you might have seen that the question binary, they first of all ask you to convert this binary into denary, and then you convert they give you a denary number and then they ask you to convert it into binary, and then they ask you to convert it into hexadecimal. See, so if I'm not wrong, the part C of this question was like, I did the question up here. Yeah, acha, it was different for this. But agar usually aapko bol de that there is a denary number which is being then converted into hexadecimal later on, it's you can literally do it easily through this too. Say, so ये ध्यान में रखना that go like either way, if you go with method 1 or method 2, you're going to get full marks. So go with the one which you find easy. For me, it has to be method 2, and I would also recommend that because the chances of making an error are lower, you should also go with that too. Now we are done with the 3 number system which we all should be well aware of. So we studied what hexadecimal is, we studied what denary is, we studied what binary is, but now we need to see that, bro, you tell me one thing. I get the concept of how computers are basically made up of what? They are made up of circuits. And we are well aware that circuits have only 2 states. They are either on or they are off, right? We are well aware of this. Because they have only 2 states, we said that, okay, let's come up with the number system of binary, which was for 0 and 1, or 2 possible states. Then I was like, okay, we humans definitely are way more complex and we need a better number system. So because we need more values or more numbers, we came up with denary, because we need more possible figures. And so we said that, okay, let's introduce a number system from 0 to 9. We're going to combine different values. So ye bhi samajh aa rahi. This also makes sense. But what's the logic behind introducing hexadecimals then? And why do we need a hexadecimal in our life? Like, what's the logic? So we need to basically look into the logic behind hexadecimal, and we need to explore the uses of hexadecimal in computer science. So we're going to see where can we make use of hexadecimal and how and why. Say, so starting off, first of all, we're going to be studying the uses of hexadecimal. Say, so we're going to study the use of hexadecimal, and then later on we're going to see that what are the benefits of hexadecimal. Say, so firstly, let's do it the other way around. Let's understand why hexadecimal is being used rather than binary or stuff like that. So if you look up here, we had this binary value. Where did it go? So we had this binary value 0 4 1 0 1 0 0 1 1 1 1 0 1 1 0, right? So yep, 0 1 4 1 0 1 0. Achha. 0 4 1 0 1 0. Okay, so we have this binary value, and now if I count this, you're gonna see that it's basically 8 bits, right? Kitne bits? 8. 1 2 3 4 5 6 7 8. Now this can be represented now as 7a. Now 7a is only taking 2 bits. Now you tell me one thing. If I ask you guys to memorize 7a, would that be easy, or would it be easier to memorize 0 4 1 0 1 0? definitely it has to be 7A, right? Because it's easier to learn it mentally. Like even at this point, I have memorized that it was 7A, but memorizing the binary is pretty much difficult. So, for why we came up with hexadecimal was that hexadecimal could represent large sort of binary numbers in a very compact manner. So now this is just an example for 7A, but you tell me, we know that each of this digit is basically representing four binary digits, right? Four binary bits. So this means that if I have a specific character like, okay, MAAZ MUNIR, which is my name, Maz Munir, let's say, okay? Or if I can also add M at the back, Muhammad Maz Munir, okay? So if I count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is basically 10 bits. Now, if I have to memorize this, memorizing these 10 characters is not that much of a big deal. Okay, I can memorize M, double A Z, MUNIR. Okay, I can memorize this. But you guys know that if I have to represent this whole hexadecimal, let's say for instance, this was a hexadecimal value. If I have to represent this as a binary, how many bits would I have taken? It would have taken 40 bits. So yes, so because each of this character will be taking occupying four binary digits and we have total 10, this means that if I have to write this in terms of binary, it would have taken 40 digits. Now you tell me, is it easy to memorize 10 digits or 10 specific bits or characters, or is it easier to learn 40 random zeros and ones with the perfect sort of arrangement, with the perfect understanding of where will that one be coming up, where will a zero be coming up, and all that stuff? It's easier to memorize hexadecimal, right? So computer scientists basically introduced hexadecimal for the better understanding of user. So like it was introduced for the purpose so that the user can easily understand what the computers are trying to say, or that if we have to deal with some binary thingy or binary logic, it's easier for the users to understand the specific code which was being represented. So now let's say you face a problem in your computer, so you might have seen something like error code. So आपके पास computer होंगे, and let's say you downloaded some game from some cracked website, okay, and the moment you turn it up, there is an error, and the error is like EXA2345 blah blah blah, stuff like this. Now what is this EXA2345 बल्कि let me show you guys a picture, सही, फिर उससे आप लोग को बेहतर समझ आएगी. Wait just a minute, let me download a picture for you guys. That would be way better. Okay, so do we have a code up here? एक second. Let me show you guys some examples of better. Okay, yeah, we do have this picture. So we have this one picture. I hope it gets loaded up. Yeah, it did. Very good. Let's give them the credit too for the picture. So let's paste the picture up here. Say, look up here, guys. So this picture is basically saying that we have a specific problem being detected on our Windows, and it is saying that it has been shut down and blah blah blah. But then it is giving us these codes: stop code, blah blah blah. This. What is this? This is basically a specific type of hexadecimal. Yes, Mo is 100% error code. No, no, that's not chapter number 2. That is chapter number 1. We are coming to that. See, ab ye jo, whatever these whole larger numbers are, these are basically hexadecimal values. And now the purpose behind why we have these hexadecimals is that each of this code, if I have to like represent 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, A, this might be representing large set of binary code. So maybe like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. So if it's 12, 12 into 4, that's like 48 digits. So if I have to write 48 digits of binary up here, memorizing it would have been very difficult. Now, why do we have this? Let's say, let's take an example. Let's take a scenario example. No, it's not coding. It's not coding. Let's say Saifullah is up here playing game. Okay, he's playing game on his PC. He's playing game on his PC, gaming PC. And then we have, let's say, Zulkarnain as a technician, a professional computer technician who knows everything about how to solve PCs. So this is Zulkarnain, okay, and he's pretty much very happy because he earns a lot of money by ensuring that computers are working the right way. And now Saifullah downloads some game up there and then he installs it. And on his screen, an error like this comes up 0x blah 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 a. Okay. And now Saifullah up here is basically sad knowing that he cannot play the game anymore. And so what Saifullah does is that he takes his PC and he brings the PC to Zulkarnain. Zulkarnain, when he loads up the computer and he runs the game, he's going to see that this error is being located. Now, because Zulkarnain would have been aware that there is an error which might include कोई नहीं Zulkarnain आपको अमीर बना रहा हूँ मैं. You know, this technician people earn a lot of money, by the way. So let's say Zulkarnain is nahi, bro, I'm saying it the right way. It's not in that term. So let's say Zulkarnain is like Microsoft senior hell, or what do we call it? Well, let's say senior problem solver Zulkarnain or whatever. Never mind. So if Saifullah has to take the PC to this senior technician at Microsoft, which is Zulkarnain is going to load the computer and he's going to see, okay, this person has the error of 0x 000a. Let's shorten it up. It's 0x00a. Now Zulkarnain would easily find out that, okay, bro, when I was being trained for this job, they told us that if an error that ends with a occurs on a PC, this basically means that the computer's power supply has been damaged. And so what Zulkarnain will do is that he's going to write a big check of like maybe 15,000. He's going to say that, bro, pay this money and your power supply is going to be replaced. And then he's going to replace the power supply and he would be like, done, easy peasy. Saifullah, यार वो chapter 5 में those examples are going to come up. इतने जल्दी नहीं disclose करना होता. Those are going to come later on. Don't worry. So अब Zulkarnain is going to replace the hardware, and now Saifullah is going to go back to his home and he would be like, oh, let's go. I can play the game, and he's going to go be happy. Whereas Zulkarnain will be like, okay, bro, I got my dollars. I'm good to go. But now let's say, why did Zulkarnain figure it this quickly? Because he knew that the person was facing a hexadecimal error of 0x000a, right? But what if I say that rather than on the screen such code, rather than these codes, if Saifullah went to Zulkarnain and he tells him, bro, tell me one thing. There is this error 01 blah 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 101010101011111101. Zulkarnain will be like, sir, just a minute. I do not understand a single bit as of what you're trying to say. So what are these 1 and 0? So even though if Zulkarnain was trained at some point about these binary digits, he might not be able to memorize. Like, it's easy peasy thinking that memorizing 0x000a is way more easier than learning this whole set of binary digits. And so it's not easy for Zulkarnain to diagnose the specific error in Saifullah's PC, right? So for that reason, the chances of making an error are again high. So, but because computer scientists want to simplify problems for all of us, they were like, let's introduce hexadecimal so that rather than showcasing this long set of binary digits, we're going to be just saying 0x7000a, which Zulkarnain can easily represent. So that's the main logic behind why we have these hexadecimal, because hexadecimals are easier to interpret and understand. So users can easily understand hexadecimal. If there are other uses, we're going to discuss them later on as to why we might be requiring hexadecimal. So एक तो ये कि users can easily understand hexadecimal values in comparison to binary. And secondly, the other logic as to why we might be making use of hexadecimal is that hexadecimal takes up less space on the screen. Takes up less space on the screen. So like, what's the logic behind this? The logic behind this is that you tell me, if I have to write a whole set of binary and I have like 7a is just telling me 8 bits, but what if I have like 7a10? So it's just going to stay, it's going to be like 8-9 characters max, right? So if I have to represent that on my screen, it's easy. I can literally easily do 7a b c d e f, but this is going to have a binary of like maybe 1, 2, 3, 4, 5, 6, 7. 7 into 4, 28 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You see, it's not even coming up on the screen. So because it's going to occupy a lot of space, what computer scientists did was that they said that let's introduce a new number system with the name of hexadecimal, which is going to take less space on the screen. So these are two reasons which are coming to my mind at this point as to why a hexadecimal number system was introduced. So yeah, so is this clear? And did you guys get it through this concept which I mentioned earlier on? Because why? Because jab we are making use of hexadecimal, it's going to be easier for Zulkarnain to figure out that what problem was this specific person or Saifullah facing. And now both of them are happy because one is earning money, whereas the other one is now playing games. So just on the side, we will be discussing a lot of such analogies. So yes, so throughout the course, I personally love explaining stuff through such things. So you're just gonna see, this is just the beginning, buddy. We are gonna do a lot of things. So Saifullah was part of my previous batch two of the October-November session. He knows a lot of other thingies which we did, all the way from Red Dead Redemption 2 to like biryanis and whatnot. So you're just gonna have a very fun time alongside that. We're gonna cover the whole topics through such examples, inshallah. So it's gonna be fun. Don't worry, we are here to ensure that you guys understand the concept in the right way. Once you get the concept, बाकी याद हो जाता है. अब आपको concept ना समझ आए, you're trying to memorize, it's not going to work that way. So we're done with this. Now we're going to study where in the computer. Now, okay, we're done. And now we saw that Zulkarnain and Saifullah used hexadecimal to ensure that their lives are easy. Now that's fine, totally fine. Yes, Zulkarnain, do you have a question? That would be done later on. Inshallah, I might start next year though. So, like for the next session, I might do start A levels. But for now, for this May June 2026, it's on the IGCSE or O level CSA. So now going on, now we have studied how Saifullah and Zulkarnain, why did they make use of hexadecimal? But now we are going to learn that when Zulkarnain was going through that Microsoft training program where he was told about how these 0x000 A's, what were those possible places where a hexadecimal could have been used? So Zulkarnain ne jahan jahan pe seekha tha that we can have an example of a hexadecimal value at this place or maybe at this place. What were those locations? So we're going to be studying that right now before ending the class, which means that we're going to be studying uses of the hexadecimal values. So uses of hexadecimal decimal values. So we basically can make use of hexadecimal at multiple places. Say starting off, we even discussed one example right up here. We saw that we could represent errors, right, through hexadecimal. So the first place where you can make use of hexadecimal values is basically error codes. So error codes is a set of, you can say, a database or error code ही बोलेंगे ना, क्या कहते हैं, yeah, error codes होते हैं. So like if I have a specific error or maybe there is some sort of problem or something, the computer, rather than telling me a binary value of it, they basically tell me a specific code that this specific error has occurred, and that code is basically written in a hexadecimal value. So these numbers refer to the memory location of the error. So I can say that if an error occurs, rather than writing the binary, it's going to represent that specific binary or maybe the address of that location in terms of hexadecimal. So hexadecimal value used to represent the memory location of a specific address, a specific memory location of a specific error, And apart from this, just one other example जो कि मैं दिखा देता हूँ. So we can also have a scenario. Yes, Moiz, बिल्कुल सही तरीके से आपने बता दिया. So अब coming to this, एक तो हमने एक discuss करी. We just had one example, but let me show you guys this one other image. This was there in your book too. So if you guys go and check your chapter number 1 on your harder education book, which I would be recommending you all to read, this is one image there in the book, which is basically talking about all possible errors. So not all possible errors, but some of those possible errors. So you see, just focus up here. 0x6 is basically saying that this handle is invalid. So like if let's say Moise goes to Zulkarnain now and he's saying, sir, that I'm playing this game, but I got this error of 0x6. So because let's assume that Moise does not study computer science, he might not be aware of what 0x6 means. But because Zulkarnain went through that Microsoft training program, he's well aware that 0x is this basically means that a handle is invalid. And so because while training he's going to learn that handle, if a handle is invalid, how we're going to be tackling that. So he's just going to implement that specific code, and he's going to make those changes which can ensure that the PC is working totally fine. But if we did not have 0x6 and rather it was something like 0 1 0 0 1 0 1 0, it would have been very much difficult. So for this reason, we have hexadecimal being used for error codes, which is the first use of your hexadecimal values. Uske baad, the second use basically comes up in what do you guys think? Okay, so we do have Moise telling us a lot of thingies. So your second use can basically be termed as IP address. So IP address is known as internet protocol address. It's not something which we are going to be studying at this point in the course. आगे हम जाके जरूर पढ़ेंगे in great detail what's IP address, but IP address in short form is a unique identification code used by your device. So like if I say that I'm a student at LUMS, right? So if I'm a student at LUMS, I have a student ID card, right? Or if you guys are at your school studying whatever IGCSE or O levels, you would have been issued a specific student ID card, which is a document to prove that you are a part of the school. So IP address is basically a document given to your computer or your device to prove that it is that you are connected to a specific internet. If I, let's say, I've been connected to this one internet and I have to provide some sort of certificate or something or an identification number which proves that this is on my device, that number is basically represented as IP address. Just keep it to this extent till now. Again, inshallah, in chapter number 3, we're going to discuss this in great detail, so no need to worry. But now the important point up here is that these IP addresses, or maybe if you have ever seen in your homes too, you might have seen values like this: 192.168.10.41 or something like this. What are these 192.1.6? This is basically my IP address. And now in this IP address, originally we had a IPv4, so IP version 4 address, which was like this. Even now in Pakistan, IPv4 is being used for the convention number system. But now we have a latest version, IPv6. IPv6 was introduced because definitely with the advancements, we observed that we cannot cover up all these possible, like definitely if I have a phone with me right now, and then I have a laptop with me, and then maybe I have a smartwatch with me, and all of them are connected to the internet, then the number of devices connecting to the internet are getting larger and larger. And it's not only for me, it's literally for every other person. And so for that, this IPv4 originally had a limited space. So it could not store a lot of characters. Originally, it was only for 32 bits. Now, again, this discussion of 32 bits would be discussed later on, but just for your own mind, why we had IPv6 coming up? Because 32 bits was the maximum capacity it could store. So like it could store up to 2 raised to power 32 location. But now because we have a lot of advancements and we saw that there is a great rise in the number of devices that are being used generally, so this 2 raised to power 32 was not enough. And so computer scientists were like, let's introduce a latest version. Now look, computers or the IP address which we have right now, that is basically eligible to 2 raised to power 128, which means that it is making use of 128 bits. So this 128 allows you to have way more capacity. And so how can we have a greater capacity? Now, if you guys remember previously, we said that denary had a range from 0 to 9, but then we came up with hexadecimal, which said that rather than going from 0 to 9, let's also introduce A to F. So the same concept was being applied in IPv6, that they also brought up those A to F wale characters into action, and they increased the memory possibility. So now IPv6 is a newer sort of technology which now makes use of hexadecimal values to store characters. So we can say that IPv6 इसको यहाँ पे कर लेते हैं. IPv6 uses hexadecimal to store values. For instance, let me give you guys an example to store values. Well, now, rather than having 192.168 or 20.41, you have observed this is totally denary. Now, the latest one have stuff like AA98 colon 447B, 8C7A, and so on. So now you see this is the same hexadecimal thingy logic, that we have the 0 to 9 from denary, and then we have A to F, which was introduced in hexadecimal logic. So we're just making use of the same logic, and we just extended the use of hexadecimal values. Ismay, just keep this in your mind. If a question comes up on the differences between IP addresses, you should be aware that IPv4 address has 32 bits. Again, this would be discussed later on, but just keep it in your mind. Whereas IPv6 make use of 128 bits. And one other difference which students can make an error is with that your IPv4 address is basically making use of dots. Say so it's 192.168, whereas when you make use of IPv6, it's like 8898 colon 447b colon. So we make use of colons. So the differences lies in colons and these what do we call it? Number of bits. So difference lies in the debate between this and this and 32 slash 128 bits. So just keep this in mind. We would be inshallah discussing this later on too. Yes, IPv6 has more storage. It's the same thing that if I have a specific slot up here and it can only store denary values, this means that we can have a possible maximum range of, like, let's say 9999. But then we said that let's introduce F. F is basically 15. So what if I'm saying F, this means 15, 15, 15, 15. Now this means that this 10 plus 5 for each, so it's going to increase the range, right? So अब इसके पीछे ज़्यादा logic में नहीं होना चाहना चाहिए, but just know that because F can now represent, rather than 10, it can now represent up to 15, we can store more data at this point. So that's the logic being used as to why IPv6 has not a more storage, we can say it has a greater capacity to introduce newer devices. Storage is not that exact word which you would love to use up here. Now, is this clear, or are there any questions till this point regarding any of the concept which we have been discussing? Perfect. Rest, Ramin, Inaya, is this clear? Good. Perfect. At this point, with the current technology, we have not yet exhausted IPv6 maximum capacity. So, yeah. But if we expect that the number of devices are going to increase tremendously, and then we need a new technology, then definitely IPv8 may come up, which would use like up to 256 bits, let's say. So then the capacity is again going to extend. Say so at this point, IPv4 might have been exhausted, and now they are going to come up with IPv6 and stuff like that. Yes, coming to the same point, Moise. Now we are done with two places where hexadecimals are being used. We saw that error codes use hexadecimal, and we saw IP addresses use hexadecimal. Now the third place where we basically make use of hexadecimal are basically MAC address. Now what's a MAC address? MAC address is basically your computer's fingerprint. So if I say that you have a fingerprint which is only unique to you, and so if I go to a specific bank or someplace and I have to tell them my sample and I share that this is my specific identification number, then your computer has a similar identification code which we call as MAC address, or media access control address. Now your MAC address is a uniquely identification number which is connected to your network interface card. So it uniquely identifies your device on the internet. So if I, let's say, go and go to Zulkarnain home, and there is his router, okay, and I connect my laptop with it. Now on his router, definitely if he goes to his settings, he's going to see that the connected computers are going to include my MAC address. So MAC address of some laptop, which is going to stay the same. IP address is pretty much also similar thingy, but again, IP address is going to differ between houses. So ye baat, again, this is something जो हम later on discuss करेंगे, not to worry about this right now. So just know that this MAC address is going to stay the same always. So I can say that now, if rather than being at Zulkarnain home, let's say I go to Moise's home, and so now at Moise's place, I might reconnect to Moise's internet, and now if I go and he checks it on his online portal, it will be having the same MAC address. So it's like your CNIC, it's your computer CNIC which recognizes uniquely that this person is yes, Zulkarnain, do you have a question? What's the difference between MAC and EMEI? Okay, that's a good question. EMEI is so your MAC address is basically dependent upon your network interface card. So that specific thingy which you connect to your computer so that it can get wireless signals. You might have seen that if you have a PC and you want to ensure that your PC has Wi-Fi access, you connect some sort of chip inside your computer, and then that has an antenna like this, like the pen which I'm holding right now. Now, the card which is connected to this antenna, that is what we call as network interface card. Now, your laptops, your phone, every device which has Wi-Fi in it, they have an access to a network interface card. Say, so your NIC provides you a MAC address. Now, your EMEI, which your phones have, that is basically dependent upon the SIM slot. So up here, if I have a SIM connected to it, the SIM tray provides me an EMEI. So the SIM tray is uniquely going to identify my phone's SIM within that specific tray. Samajh gaye? So your MAC address is being used by your network interface card, whereas your EMEI is basically provided by that SIM capacity or the tray, say the specific tray SIM slots. So EMEI is not part of your course, so you don't need to worry about that. But just keep it in your mind that this was just a general point. बाकी कहीं लिखना नहीं है कि आप EMI के ऊपर बताने लग जाओ. That's not relevant to your course. So now the point here to note is that your MAC address uniquely identifies your device. So let's write this up here, and it uniquely identifies your device firstly. And इसके बाद second point ये है कि your MAC address is basically specific character which exists in pairs of six. Say pairs of six ही बोलेंगे. So it has basically a format like N, and then it has D. Now, what's this? It's basically a method of how you're going to be writing your MAC address. So your MAC address is written in this way, and it's basically written in this way for one reason. The first three pairs, the N one apart, they basically demonstrate the identification number of the manufacturer of the device. So this is basically identification of the manufacturer. And then these three are basically going to sort of tell you the identification of the specific device. It's pretty much used everywhere. Like for instance, if you even have your CNIC with you and you look up at your CNIC, at the first five digits are basically going to be indicating what specific region do you belong to. So your father or your parents, your family members, they're going to have the same first five digits. Why? Because that's going to identify what region you belong to. And then after that, you have those unique numbers coming up, which uniquely identifies you. The same logic is being applied at MAC address to the first six digits. So like if I have a specific code, like let's say if I have a MAC address like 001C B3, and then I have something like 7A9B A2, then this is basically a MAC address for a specific device which has been made by Apple. So this 001CB3 is the hexadecimal or not hexadecimal, your hexadecimal sort of MAC address for your Apple device. So MAC address of all Apple devices, And the code which I wrote afterwards, 7A, 9B, A2, this is basically a unique ID of my device, So whatever that device is. Now, if I have a different device, so let's say I make it up that this is for some MacBook. Now, if I have my iPhone with me and I check iPhone's MAC address, the first six digits are going to stay the same. Why? Because definitely the manufacturer for both iPhone and a MacBook are the same, whereas only the unique ID is going to change. Now, the point here you all need to know is that your this way of representing your MAC address, that is also going to be including hexadecimal letters. So right now, this 1C, B3, A, and B, they're all hexadecimal values. So we can say that hexadecimal values are used to represent the MAC address. समझ गए? Apart from that, the logic behind how MAC address and IP addresses and all this stuff work, that is going to be discussed later on, inshallah, once we get to chapter number 3 and chapter number 4, and we are going to discuss those whole routers logic. So jab hum unko discuss karenge usi dauran, we're going to deeply going to study all this too. So for now, you just need to know that we are making use of hexadecimal here, because the question might come up and say that where can you make use of a hexadecimal? So you can say error code, IP address, MAC address, and you can also talk about HTML and all that stuff. So we would be doing that tomorrow. It's 9:50, and because I have to leave a bit early, we're going to continue with the uses of hexadecimal, inshallah, tomorrow. We are left with one last use, which is basically through HTML. You might have heard the word HTML too, if you are someone who might have explored web development. So you're going to look into how hexadecimals are also used there. And inshallah, after that, we would be discussing addition of these binary values. So we know that 7 plus 2 is 9, but how do you do 0 1 1 0 plus 0 1 1 1 0? So we're going to be studying addition and subtraction and those things, inshallah, tomorrow's class. Tomorrow would be our last demo class before officially starting off with the registered students. So if you guys have not yet registered for the course, I'm going to reshare the form. You guys can fill that out, and our TA would have would add you guys into the group. If you guys have filled the form and have not been added to the group, you guys can reach out to me, and we're going to cater it out, inshallah. Thank you so much, Moiz, and good luck to all of you too. Baki, you guys can share all the recordings with your friends too. They are being posted on our YouTube channel, and you can spread the word about our course. So take care, everybody. See you guys tomorrow, inshallah. Allah Hafiz. Bye bye. Allah Hafiz.